All right, yeah, just been hella overthinking this, and because of that, we're just gonna get right into it. I'm gonna post the links to the books in the description. You guys can go check that out and follow along. Okay. Consider two displacements, one of magnitude 3 and another of magnitude 4. Show how the displacement vectors may be combined to get a resultant displacement of magnitude 7, 1, and 5.
Two displacement vectors. I'm going to label one x1, and that is 4 meters. I want to label the second one x2, and that is 3 meters. Remember that these are both vectors, okay? So we have units on both of them, meters, all right? And also remember that these guys are both facing the same direction. They're both positive. And so it's asking us, how can we get a resultant vector? Well, so I'll say xr1 of 7 meters. Okay, also, what about xr2? What about, what did it say, 1 meter? And xr3, what about 5 meters? Okay, well, mathematically speaking, we can already see how we can get 7 and 1 from 4 and 3. Alright, so 4 plus 3 equals 7. Alright, but we're not working with just numbers and values here, we're working with vectors. So how can we say this in vector form? I can say xy, alright, plus x2, alright, equals xr1, as xr1 is 7 meters. Okay? So all you're doing is a little substitution jutsu, and we just sub in those values right here, 4 meters in the positive direction and 3 meters in the positive direction. And how do we go about getting 1? About x1, okay, minus x2, okay, equals xr2. And xr2 is going to be 1 meter. Let me draw this out for you. That's 4 meters in the positive direction, minus 3 meters in the positive direction. Okay, that's going to equal 1 meter in the positive direction. Same thing for this guy. Alright, well, how do we get 5? Okay, so essentially what we've done is we have two values here. We have one that's 3 meters, right? And another, let's say, I'm just going to call it a measuring stick, which is 4 meters. These are non-uniform measuring sticks. One is 3 meters and one is 4 meters. Okay, we've put them together. When we added them together, we get this long measuring stick that's 7 meters. We have a measuring stick that's not the scale, 4 meters. Alright, another measuring stick that is 3 meters. And when we subtracted one measuring stick from the other, we've ended up with this space here. And that space is 1 meter. Alright, well, how do we get 5 meters? How does that happen? We all know about the Pythagorean theorem at this point, should. And right triangle, okay. Have we ever heard of a 3, 4, 5 triangle? When two sides of the right triangle, one of length 4 units and another of 3 units, that hypotenuse, wow, I cannot believe I just remembered that word. That hypotenuse is 5 meters. Alright, this is a ratio, right? 3, 4, 5. So basically, if we multiply this by any number, let's say 5, and we would get 15, 20, and 25, okay? That ratio would be exactly the same. Alright, it would be 15, 20, and 25. 15 where the 3 would be, 20 where the 4 would be, and 25 where the 5 would be. Alright, so it's just a ratio, okay? How can we say this mathematically speaking? Okay, well, we know that, okay, a squared plus, alright, b squared equals c squared. Let me get to it. Alright, in order to find c, alright, we're going to say square root a squared plus b squared. Alright, well, what does that look like? Okay, here, our b is our what? It doesn't really matter. Let me say, hey, b. Our b is our 3, our a is our 4, and our 5 is our c. The c has to be the hypotenuse, right? C has to be the hypotenuse. I'll even make it a little bit more clear for you guys. Boom, red. Okay? Alright, so in order to find the hypotenuse, we square root everything, c equals, bam. C equals, so let's say, so essentially I'm saying 5 equals square root of 4 plus 3. Right? How do I explain this in vector property terms, right? In the terms that they gave us. So if our resultant vector, xr3, was 5, and our x1 was 4, and our, look at that, my mistake, these are supposed to be squared. Alright, boom. And that's how you get that. That's how you get that, baby. 5 meters in the positive direction. Oh, whoa, wait. Hold on just a second. Hold on. Okay, yes. And I think I remember in the back of the book, this is not a positive direction. I'm sorry, let me go ahead and take that off. I think I remember in the back of the book, it told us that these are perpendicular, okay? So in the first answer, we get a result that is in the positive direction. Alright, we've put these we put these measuring sticks in parallel form and added them together, right? Here, when we subtracted them, we put them in parallel form and we subtracted them. But here they're not parallel, okay? Okay, here they are perpendicular to each other. All right. And so this would be, I don't even know what I would call this, what kind of term I would put for this, but it's not parallel or perpendicular. It's halfway. Okay, it's 45 degrees. All right. So that is question number 1.